Good afternoon, everyone. My name is Gary Allen. I'm the president of the Maryland Forestry Foundation, and on behalf of the webinar series, Framing the Future, we'd like to welcome you today on our June program, 2023. These topics are recorded. You're pleased that you could join us today. It's my pleasure to be the host of these sessions. As you know, we continue to look at issues of significance to framing the future of forestry in Maryland, both policy, program, and project. So let us welcome you today on a very interesting and useful topic that's proven to be an informative one and a critical one for some of the recent legislation passed in this area. Joining us today will be one of our key researchers in this area. And so I'm going to turn it over to our moderator, Megan Carr, one of our first fellows, Mel Nolan fellows. And by the way, the program is open for application today, which I'll mention a little bit later in the program. Let me turn it over to Megan and to introduce today's panelist. Thank you very much, Megan.
Great. Thanks, Gary. Yeah, we're very excited for today's session to hear from Dexter Locke on a few research topics, mostly focused on the legacy of redlining in Baltimore City and its impacts on tree canopy. For us in Baltimore City, obviously, that's a huge issue of concern, and very excited to learn more about contemporary research and new findings. Just a quick reminder for folks in the audience, so we are able to take your questions today. Please do feel free to add those into the Q&A box at the bottom of your screen. You can also use the chat box for general discussion with other attendees, but if there are topics that you would like to hear Dexter address, please enter those in the Q&A. So we'll jump right in. Before joining the Urban Forests Environmental Quality and Human Health Research Unit as a research social scientist, Dexter was a postdoctoral fellow at the National Socio-Environmental Synthesis Center, also known as SISYNC, which is part of the University of Maryland. He's an urban ecologist with degrees in geography, environmental science, and natural resources planning. Conducting applied research with urban natural resource managers is his passion, but when he's not doing urban ecology, he can usually be found rock climbing and hiking throughout the Mid-Atlantic region or listening to classic rock. So very glad to have Dexter back with us again, and I will turn it over.
Thanks, Gary, Megan, everyone for attending. Really excited to share with you some research, some published, some in progress. See if I get this. Are you seeing my screen?
Yes.
Great. So I was asked to speak a little bit about redlining and present some new findings. Some of this may be familiar to you before. I've been talking about redlining and tree canopy for a while now, and I'm always excited to share some of the latest research. So basically, I'm going to go through 4 different studies, and hopefully they're going to share a narrative arc about race-based policies and urban tree canopy and urban ecology more broadly today. I'm going to talk briefly about urban tree canopy, a study we did across 37 cities. The second piece focuses on Baltimore City and on street trees, species and size, and how they are predicted by the legacy of redlining. And then I have a just accepted piece on bird observation. So citizen science or volunteer geographic information from volunteers and how that varies by redlining. I'll talk more about why we might think that is, and then share some very fresh, not yet written up results looking at more than just birds, looking at reptiles, amphibians, insects, fungi, and more. So why should I be interested in redlining? If you're interested in forests, natural resources management in Maryland, why should I be interested? Well, first of all, it's a fascinating history, I believe, but more practically, today, the money. Chesapeake Bay Trust has criteria for its grant applications that include urban, low income, formerly redline, high unemployment, and public housing areas. And part of this application process, they made it very easy. There's a web map you can click and see in an online GIS or mapping software where these different types of areas overlap. And funding was tied to this. So criteria for receiving grant funding for urban tree planting from the Chesapeake Bay Trust was guided in part by this criterion, among others. So that's another reason to be interested in race-based zoning and tree canopy today. So very briefly, the Homeowners Loan Corporation, which was set up coming out of the Great Depression, the idea was to insure home loans to prevent Americans from default. And foreclosing on a home can have a cascade of economic impacts. And so the idea was to rate neighborhoods from A, which was green on maps, B, then C, then D, and declining credit worthiness or perceived risk of default. And then loans and insurance would be given in a way that matched that. And so the intention in some ways was commendable, was to prevent economic collapse and coming out of the Great Depression. But some of the other criteria are suspicious at least, or malicious at worst. And from a research perspective, the practice of redlining, so-called because the degraded areas were red on the map, from a research perspective has some important characteristics. It was consistent. It had this racial component, as I just mentioned. I'll explain more in a moment. It was spatial, so on maps, we can tie that to other geographic features through mapping software today. It was applied over a relatively short period of time, so from the mid to late 1930s and a little bit into the 40s, and widespread. The 239 largest metropolitan areas in the US were mapped in this way. So here's an example from Baltimore, where I do a lot of my work. Quoting from this example, an old residential section seriously threatened with Negro encroachments. A small section of Reisterstown Road consists of fairly modern two-story brick rows, that's short for row homes. It goes on to describe the demographic composition, occupations of the inhabitants, the population according to census. Favorable features: Druid Hill Park, as many know. This was designed by Frederick Law Olmsted, who designed Central Park and many other iconic parks at the time, and good transportation. Detrimental features: obsolescence and Negro encroachment. So quoting from the Homeowners Loan Corporation assessment, their words, not mine, you can see how there's a mix of built environment and amenities and disamenities and occupations and demographics were built into this. So the green areas were considered best, then blue, C, and yellow, and then D, hazardous. And so in Baltimore, we have about 17,000 vacant homes, another 14,000 vacant lots, although that varies, and those are surprisingly difficult numbers to get for a number of reasons. And on the right, you can see the same map as before, and each of those black dots is either a vacant home or a vacant lot. And you can see this overwhelming preponderance of correspondence between vacancy today and the inability to garner these types of loans and insurance in the past. And so this type of disinvestment 80, 90 years ago is very much reflected in the built environment and landscape today. And it's not just among environmental things like tree canopy, which I'm very interested in, and many on this call, but redlining has been studied by many branches of the social sciences and looked at health, social determinants of health. What we consistently see is higher poverty and unemployment, lower educational attainment, poor measures of health and credit scores through. At this point, the literature has now received multiple kinds of meta-analyses and systematic reviews, and the pattern is consistent. So what about environmental things? What about the built environment? We know trees reduce urban heat islands, as well as provide many other ecosystem services in urban areas and elsewhere. And that disproportionately affects vulnerable populations. So the sort of logic model of this paper was, if there were larger lots in A-graded neighborhoods, because they were predominantly single-family detached homes compared to denser housing like row homes and apartments and things like that, there would be more space for trees. Also, we know that A-graded neighborhoods had more access to power, greater wealth. And we know from qualitative archival research in Baltimore that the location and allocation of street trees and the distribution of parks and open spaces very much was influenced by Baltimore's elite. And there's less parks and open space among lower income areas and communities of color. So those are two plausible explanations for why we would see greater tree canopy today in A than in B, than in C, than in D. And of course, trees are fundamentally slow growing organisms. So by looking at zoning policies of the past, they ought to predict the canopy we see today. And so this was a paper I led. It's been downloaded more than 21,000 times now. And we examined these 37 cities where we had high resolution tree canopy, which Baltimore is a leader in, and those methods were developed here in Baltimore. The Chesapeake Bay Conservancy now has a great layer that does all 200 and something municipalities and jurisdictions in the entire Chesapeake Bay with a 12 class land cover. But here we're just looking at tree canopy. And in large cities, we can look within cities A to B to C to D. And then on the smaller cities, we get to look across. And what we found was formerly A-graded neighborhoods at about 43% tree canopy cover today. And that's controlling for cities. The baseline tree canopy in Seattle is different than Tampa, Florida. So we incorporated that in the analysis. And formerly degraded neighborhoods of about half that, or 22%. So it's not only statistically significant, but when I explain this to audiences that are unfamiliar with tree canopy, imagine you have 43% of an umbrella on a rainy day, and then imagine you have 22% of an umbrella on a rainy day. It's not only a statistically significant difference, it's a very meaningful difference in the benefits of trees. And so focusing on the 10 largest cities, you can see from left to right, the rank order of tree canopy matches the rank order of the homeowners loan corporation grades. So in summary, we know trees provide benefits. Prior city-specific research in Baltimore using archival methods and interviews, other historic methods, showed that redlining did play a role in the location and allocation of trees. We wanted to see if the patterns were similar in other cities, and yes, they were. And so we think other research can continue to build off that. We made all the underlying data available. We have more tree canopy maps today. The University of Richmond, who digitized the whole polygons, has since released a greater set of redlining polygons. So it's really ripe for additional analyses. I would be remiss if I didn't mention other related research. I know of at least 3 teams that have looked at this question of present day tree canopy distribution and redlining. This one on the left used the National Land Cover Data Set 2006, 2011 look at change. The one on the right looked at the National Land Cover Data Set and also looked at impervious surfaces and surface temperature and heat. And we know heat corresponds well to tree canopy. It's inversely related. The bottom one used a dot-based sampling method and modeled some ecosystem services. And Gary asked me to highlight this. It's really rare that we have 4 different research teams, these 3 groups plus my own team, that used 3 different data sets and 3 different teams and came up with the same results. More common, we see coffee causes cancer, and 6 months later, a new analysis that says coffee prevents cancer, and then a year later, coffee causes cancer, and back and forth and back and forth. It's very rare that we see all the research pointing in the same direction. So 4 different teams, different methods, different data, same findings. It's really gives a lot of confidence in these research findings. So quickly here, just to show the rank order of tree canopy using these coarser data sets from 2001 and 2011. Again, cascades A, then B, then C, then D. On the right, we're seeing higher surface temperature in D than in A, because the tree canopy is greater in A than in D, and impervious surface is more similar to our surface temperature in that it goes from A to D, low to high. A word of caution about some of the coarser remotely sensed data. This is Columbus Circle in New York City. This is Central Park. This is Landsat. So it does pretty well at picking up the larger contiguous blocks of tree canopy. Here's the high resolution data. It does a lot. It does more to pick up the smaller tree canopies. So we used 37 cities where we had this detailed data. The other data sets cover larger. So the Hoffman study and the Naiman study looked at more than 100 cities, so a greater sample size, but they missed some of the smaller patches of tree canopy. I just toggle back and forth. So they're a little bit different, yet the same overall pattern persists. I'm gonna skip ahead. So that's tree canopy, 37 cities. Other related research groups are finding the same pattern. I'm going to pivot now to street trees. And street trees are really interesting for a number of reasons. In most cities I work in, most of the land is private residential. Most of the tree canopy is on private residential. And most of the opportunities for additional greening are also on private residential. So New York City has 750,000 forest owners, private residential landowners. In Baltimore, it's about 220,000 residential landowners with with tree canopy. So it's a very distributed resource with a lot of different motivations, capacities, and interests. But with street trees, it's a little bit different. You can think of the spatial scales on the left, so neighborhood, region, national, international, and temporal scales on the right. So daily, weekly, monthly, and rare or never, longer than years. And so street trees occupy this really interesting space where frequent daily contact in the neighborhood location. And also from a management perspective, we tend to have one or very few players. So in DC, it's part of transportation. In Baltimore, it's rec and parks. In New York City, it's Parks Department. And so it tends to be one agency or an agency and a nonprofit. So there's very few players involved as opposed to tens of thousands or hundreds of thousands of players in the case of private residential land. So street trees occupy a really unique space in the urban forest because jurisdiction is granted, and we have these sort of daily and frequent and small spatial scale interactions every day. So looking at Baltimore, again, looking at a redlining map, Rec and Parks has this great street tree inventory on their website, conducted by the Davie Resources Group. This was a study led by Karen Berghardt, professor at University of Maryland in College Park, in entomology, Megan Avolio at Hopkins, some of my Forest Service colleagues, Morgan Grove, Nancy Santi, and then Chris Swan at the University of Maryland, Baltimore County in geography. And so we downloaded all the street tree locations, and then we wanted to make sure we were sampling equal size areas. We created this honeycomb pattern, so they all have the same area. And so within those hexagons, we can count up all the street trees by species and size. And this is a species accumulation curve. And the way this works is we can march through the data set. And so we've got a red maple. And so now we've got one individual on the horizontal and one species on the vertical. Let's say the next species is a swamp white oak. So now we have two individuals on the horizontal and two species on the vertical. And then we can continue, and let's say we had another swamp white oak. So now we only have we have three individuals, but only two species. And if you continue to march through that data set, you accumulate individuals on the horizontal axis and species on the vertical. And as you keep going through, it creates this asymptote, and that's how you know there's no more species. And so these mathematics are well worked out in rural areas. And if you keep sampling, you're not going to uncover more species. So it's called a species accumulation curve. And actually, we do it, and we randomize the list so we can get a confidence interval around it. And what we see here is that the species diversity in formerly redlined areas in Baltimore is significantly lower than in C or in A and then B. And ecologists and methodologists argue for good reason about should we be using species richness, as I've showed here, or if we should be using something like evenness or different diversity indices. And so we did it three different ways. And what we find is, again, the rank order, A to B to C to D of neighborhoods matches the species diversity of street trees today. So why does that matter? Well, As we know from the past, if you have a monoculture, we've seen in the past Dutch elm's disease and all the elms that were near each other were vulnerable to Dutch elm's disease and had to be removed. Emerald ash borer, Asian longhorn beetle, and on and on and on. And so if we have greater species diversity, we have a greater resilience and insurance policy that the next stressor, the next urban forest pathogen isn't going to wipe out all of the street trees because we have a diversity of species and not every pathogen can handle different hosts. So the takeaway here is it's more species diverse for street trees in Baltimore in A than B than C than D. We parse that by tree size. So large trees, 20 inches or greater, and then small trees, 5 inches. And so size is not a perfect proxy for age, especially in an urban area. We see these stunted street trees that are almost like bonsai trees. Nobody knows how they've been living in these tiny little tree pits forever, but it takes time to get large. There are no young, large trees. So that's why we use size. And by leaving out the 6 to 19 inches, we kind of sidestep that problem a little bit more. But the point here is that we have significantly greater number of large street trees in A than B than C than D. So this makes sense. You know, redlining, it takes time for street trees to grow. And so there's sort of a window into the past. And so the trees that were planted during redlining would be larger today. And from a lot of other research I haven't shared today, Rec Parks and Blue Water Baltimore and Baltimore Tree Trust and many partners have seen that lower income areas tend to have lower lower canopy. Consequently, many of those formerly redlined areas have been specifically targeted for street tree planting. And we see that signal too. There's a lot of younger, smaller street trees in formerly D and formerly C areas than their B counterparts. So what's the future of the urban forest? Nobody knows, but we do have lots of smaller street trees in these formerly redlined and yellow-lined areas. And so that might even out the inequities that we've seen in the past. So I want to pivot again. So that was sort of the second chunk. We've seen that tree canopy and how street trees in Baltimore vary with redlining. It's a very thought-provoking paper came out a couple of years ago where Chris Schell and colleagues said, well, if the distribution of parks and open space and tree canopy varies by redline and by city, true, my research bears that out, other research bears that out, we might see different traits of different urban mammals and other organisms, non-human, non-plant animals in urban areas. There might be actually urban evolution and selective pressures for adaptation that favor different traits over others. Or in C here, we might have different species richness. So birds live on trees. We have a different amount of tree canopy in A than B than C than D. We have different species richness in our urban forests or with insects. And then down in D, well, if trees are urban vegetation are sort of the base of the food web, and then insects on the trees, and then birds that eat the insects, we might have entirely different food webs today, in part as a legacy of race-based zoning in the 1930s. So some of my colleagues wanted to test that. This brings us to third study, which was just accepted. I can't wait to share it. We're just working our way through that with the publisher on getting this available. But the overarching research question was, how does sampling density of bird biodiversity vary with redlining after accounting for environmental and climatic differences? So the motivated team, Diego, is really the point of the spear on this. He brought us together. He's a PhD student at Yale right now, wrapping up. He's a NASA fellowship. And Millie Chapman just finished her PhD at Berkeley and is working at NCEAS, which is kind of like SYSINC. It's the National Center for Ecological Analysis and Synthesis, and both of them are incredibly talented and people to be aware of in this area. So we took the GBIF, the Global Biodiversity Information Facility, which is an aggregator of citizen science data. Citizen science goes by a few other names, but the point here is it's volunteer geographic data about biodiversity of all stripes, birds and plants. iNaturalist goes into GBIF, eBird goes into GBIF, and also individual studies from researchers like me and my colleagues can be uploaded to GBIF. Museum collections, so even fossilized records can be included. So we downloaded about 10 million bird observations in the last 20 years in close to 10,000 Holk-defined neighborhoods. So that's in 196 Holk-defined areas. Present day, the census would group them into 143 metros, which are in 38 different states. And so we downloaded all this 10 million observations from birders, and we intersected them with redlining maps. So what did we find? We found sampling density. So this is the number of observations per area. Again, follows this A to B to C to D pattern. So this is just, it's not saying there's more birds, there's more effort among volunteers to search for birds in A than B than C than D. Completeness, again, we're using the species accumulation curves I introduced in our street tree paper. And so we can estimate how much of the community we think we've captured. And what we find is that the completeness is significantly greater in A than B than C than D. That's just sort of the raw data, some more sophisticated modeling that takes into effect vegetation. So NDVI, the normalized difference vegetation index. So how green is the area? The PAD US, that's a data set created by the USGS. They aggregate local maps on parks and open spaces and protected areas. So PAD is Protected Areas Database for the US. Thanks USGS if you're listening, great data set. And then population density from the census. And so what we find from these models that take into account or condition our estimates on greenness, protected open space, and population density, in our combined data set, what we find is the sampling density A versus D. D is 73% lower volunteer geographic information about birds than in A. So it's a significant disparity. And we parse that by the data providers. So I mentioned GBIF as an aggregator of open science and volunteer data. And so eBird is by far the biggest contributor for birds. We see that same pattern. The same pattern is true. It's kind of compressed on this scale, take my word for it, with iNaturalist. And then with the other, it's a little bit more varied. Shifting to our second dependent variable, the predicted completeness, we find greater completeness when controlling for greenness, open space, and population density. And this is important. There's a whole cottage industry doing species distribution modeling and climate change. And so what I mean by species distribution modeling is if you open a book, a field guide for, let's say, trees, and it shows you a map of where white oaks grow, and it's got a map of North America, there's some blob of the range or extent of white oak. A lot of work goes into making that. Similarly, for birds or insects, you could open a field guide and see a polygon representing where you might find that species. And those take into account observations of those species. And the citizen science data, if it's not up to a certain threshold of completeness, it's just not even considered. It's just not even part of the overall spatial model that creates that, even if those species were collected and verified in those locations. So a lot of this data collected doesn't meet a threshold of completeness in formerly D or C graded neighborhoods to be included in species distribution model. So that means a lot of the maps drawn today, predicting species of vegetation, birds, insects, mammals, and so on, is plausibly underinformed or even incorrect because these known observations are discounted. Take a map that's perhaps incorrect today or not as accurate or precise as it could be, and now I mentioned there's this whole cottage industry that intersects that with a climate change prediction of where those species going to be in the future. Northerly climates as climate shifts or higher elevation sites. If we take an erroneous map with a prediction, we might have an erroneous map in the future. So a lot of the citizen science data that could be included is not, because the degree of completeness doesn't meet a threshold that a researcher would prefer. So not only is there a gap between A and D, but that gap is growing over time. We were analyzing bird data for the last 20 years, and this gap is actually a 40% increase. And I just want to give a shout out to the anonymous reviewer number 2. We didn't submit this in our original paper, and the anonymous reviewer said, well, how is this changing over time? And so it did take a lot more work to do that, but we're grateful because we found out that actually this disparity is increasingly growing. So 40%. And again, by source, we can see eBird really drives the trend. iNatural, it's not a lot of variation, but also through the vertical scale, it's not a big contributor in the overall data set. And then the museums, the individual researchers follow that A to B to C pattern in the raw, unadjusted analysis. So we have predictions for every city, 143 of these, and I'll just show the Baltimore, Columbia, Towson metropolitan statistical area here. We do see this citizen science gap from A to B to C to D. So it's not that the biodiversity is different per se, it's that our data about biodiversity is more disparate. So that's the third piece. And so what's next? This is in progress. So this is similar to what I just showed. It's a slightly different download of the bird data. And one of the things that came out in one of the social determinants of health and redlining meta-analysis papers is the importance of including the non-graded areas. So let me move back in my slides. So here, it's important to show that the redlining pertains to the residential areas as they were in the 1930s and 40s. So all this white area either isn't residential or wasn't residential back then. And so one of the things some of these meta-analyses folks were asking is really we should be considering the ungraded areas as a proxy for wasn't developed in the 30s or wasn't residential in the 30s. So we decided to include the urban area, which is a census designation, or the MSA, metropolitan statistical area. So this is just a simple model of density by the grade by the metro area. It's kind of rough. So what do those look like? So here's a map of the urban areas are the smaller purple polygons, and the larger gray areas are the metropolitan statistical areas. So here we're looking at Ohio. The Columbus UA or urban areas is much smaller than its metro area. They use slightly different criteria to draw these maps. So we see a little disparity over here in Akron. Let's keep it local. So that the Baltimore MSA includes Hartford and Baltimore County, Baltimore City, Columbia, Howard County, Anne Arundel, and so on. So we use these two different definitions of the non-graded urban areas. So why do a project once when you can do it 9 times? Do it again for amphibians and fungus and insects, mammals, plants, and reptiles. So that's what we did here. And with fungus and insects, it's actually really difficult to identify down to the species level, especially for volunteers, but also for experts. There's millions of types of fungus and hundreds of thousands of insects. So we did it at the family level as well as at the species level. So I guess we did this at 11 times. So it's 9 in total, right? Why do a project once? We can do it 9 times. And what we found is that the pattern with birds, A to B to C to D, is not at all exemplary. So in amphibians, A and B and C are similar. There's kind of a bump up in B, but it's not statistically significant. The larger metro area is no more different than chance. Fungus is up and down and up and down. It's not statistically significant from the 0 line. Mammals, looks like maybe there's a signal with A and B and C and D, which is kind of similar to insects. We're still trying to figure out what's going on here. And that's for density, so just the amount of information per unit area. Here's the completeness. So focusing on birds for reference again, we do see that A to B to C to D, completeness ramp, but completely bucking the trend in the non-bulk areas, almost complete sampling. Almost all of the bird species we would expect to find based on the mathematics behind species accumulation curve are observed by volunteers, almost 100% complete. And we see with the other taxa that actually the non-graded areas, so they tend to be the less urban areas, we have much higher and statistically significant greater completeness than we do in our residential neighborhoods as they were in the 30s. So very preliminary. We haven't incorporated other controls. I just wanted to share that the birders, many of my good friends are birders, not representative of the entire collection. So we need to tighten that up and add in some control variables and some other counterfactuals. But what's next? We've got sampling density and predicted completeness, but what we really want to look at is functional diversity and community composition. And so going back to Chris Schell, do we have completely different food webs? Well, we can't do that exactly because a lot of our data is not co-located. We don't know that the insect was on that plant. But what we can do is say within the insects are these different communities, A to B to C to D, or urban area or metro, or within the fungus community, is that different by redlining? Again, because if the vegetation is different, the insects might be different, the birds might be different. So one more aspect of urban ecology that might relate to the legacy of redlining. So in summary, I've shared with you four unique studies, 2 that are published, 1 that's almost published, 1 that's in its very infancy, sort of the data analysis phase, that all show this link to redlining in the past. So it's been a privilege to share with you. I hope that was interesting. I hope we have a nice discussion. I'd be happy to take any questions. And I think Gary has a couple of announcements as well. Thanks for your attention. Feel free to reach out.
That was great, Dexter. Thank you so much. Yeah, I was over here taking a lot of screenshots of some of your figures because it's a lot of what you're delving into is really relevant for us in Baltimore, especially, of course, but also has, even with like the sampling density and the citizen science reporting, has some really interesting management implications. Before I talk more about that, I'll remind folks, your questions are very welcome, so please do add those into the Q&A section so you have an opportunity to have those questions answered. But yeah, I'm really glad that you delved into the other taxa, even if the additional work of repeating your research a few times over is substantial. Since I'm part of the natural areas team and we do a lot of invasive species management, and since we're a small team, we do use citizen science reports for things like early detection species. And so we've been really concerned about, are we getting reporting from throughout, a good diverse sampling of Baltimore City and not just from, more resource neighborhoods, because we don't want to focus all of our management efforts there for some of those control methods that we're putting in. So, yeah, it's not going to be an excuse for us to not go out and do additional surveys to supplement those, but I'm glad to see that there's good representation, or at least fairly consistent representation in terms of plant taxa sampling across the different historical patterns. Well, Gary, you have your hand raised, so if you would like to weigh in while we wait to see if other folks would like to add some questions into the Q&A chat.
Yes, I would. Dexter, first, let me say thank you. What a collection of studies that have so significant implications for our thinking about urban community forestry. I note that as I was thinking about it, having been like you involved in urban and community forestry for some time, I was reflecting on the variety of benefits we almost inevitably cite for urban and community forestry in almost every presentation that you hear about forestry in general. And as I thought about that and the comments on the studies that you were providing, I couldn't help compare the data with some of those cited benefits. And one of the benefits that almost always stands out is access to nature. And talking about the presence of trees in an area provides greater access to nature. And your last study kind of highlighted that, although I must admit, as a novice in some of this area, I would have some challenges interpreting some of the details of that study, but it raises a question in my mind, in fact, two questions about how you analyze the data and studies that you're still working on. And let me mention those to you. The first is, if access to nature is a product of the presence of greater densities of trees in an area, and redlining reflects that there are greater presence and biodiversity in some of the redlined areas in the past, do you anticipate seeing some implications of that for the populations that lived in those redlined areas? And the legacy of redlining is a less of an appreciation for the role of nature in the quality of their life in an urban area. In other words, do you think it will be reflected in the attitudes of residents in those areas? And is there any way in which we could look at the implications of that, since frankly, some of the minority populations historically have been less enthusiastic about these range of benefits than some other populations in urban areas? So I'm just wondering if there's any data about how access to nature is reflected in an appreciation or valuing of nature.
Yeah, really interesting. A couple of great points there. With respect to birders, which is an area that I'm new to and grateful for the expertise from Diego and Millie. There has been a lot of work on who's birding, and that definitely skews white, older, male. And so there are studies on who's doing that. There's fewer studies I'm aware of about who's uploading the citizen science data. So we know the areas of where that sampling is occurring, and we can tie that to census, but that doesn't say who was doing it. So there's a mismatch there. So the points come in anonymously, so it's tough to retrospectively try to do that. Some people try to do that with census, but I can live here and go there to go birding, and there would be a mismatch there. So that's a methodological issue. And then I really want to highlight Deja Perkins' work. As a master's student in North Carolina, she compared 4 cities and looked at where the citizen science are going, their demographic breakdowns, and then her data collection complemented using a systematic random grid to fill in the observations that the birders weren't getting. And so not only does she report on the demographic composition of the birders there, which again, predominantly white, older, sometimes male, sometimes skewing male. But then also the places they're missing and then going and comparing to the bird data that she collected and her research team versus what the volunteers collected, and they're not the same. So there's a gap. We do have this thorny issue, and so we're just starting to get started on this issue of like, is there more bird biodiversity or other taxa, or just more sampling? And that's what our species accumulation curves are trying to get at. I see a question from Hussein, and that's one of the strategies is, given the data we have and some sound, well worked out mathematics, what's the richness we think would be there and how close are we? So we're starting to inch towards, to me, the goal, the main question, the $100,000 question we're after, that Chris Schell and colleagues put out there is, are there really different food webs? Are there entirely different ecologies? And the volunteer data is not going to get us there because it's not co-located. But what we can do is say, within a taxon, are the mammals in A than B than C different within a city, or A in Phoenix versus A in Tucson, or B in Baltimore versus B in Philadelphia, or B in New York City, and the species accumulation. And there's a different method we would use there, also based on permutation. Yeah, so those are some of the ways we're trying to get at that. We don't have all the data that we would want to answer some of those questions, but we can sort of point towards it in some of those ways. So Hussein, I hope I answered your question as well.
It was very helpful. I want to follow it up quickly with one more, and that is the other implication is, if you have less biodiversity and less urban forests in some of the redlined areas, have you compared that with the health impacts and the differences in the health impacts? Since, again, one of the ascribed benefits of the presence of trees is to provide some health benefits to an area. So you would expect their absence to provide the lack of those benefits in those areas. And I'm wondering if there's some studies that also correlate with your work in that area.
Yeah, I saw a paper looking at like biodiversity and gut microbiome and health, and basically more biodiverse environments and stronger immune responses among people. Let me see if I can dig that up.
Well, I don't mean to go off on a tangent too far, but I really hope that we can come back to a couple of these questions in the future. And I really feel that your presentation has raised a lot of issues that a lot of folks have real trouble articulating effectively, and your work is really helping us hone our understanding of these issues in a way that many people have struggled to understand. Thank you.
Sure. Thank you for the opportunity to share this work. And I really want to mention in response to one of your points, you look at like Baltimore Green Space, Katie Lauder and her team, and the sampling that they've done is in these forested patches, some of which are informally redlined areas. They have an incredible amount of biodiversity. There can be this misconception that because what I call, urban forest patches, urban woodlands, and the whole natural areas conservancy and the whole network of folks, and Megan and your colleagues in other cities, there can be this misconception from the public that because it's urban, it's somehow degraded or less species diverse. And, within Baltimore City, we have such a variety of site types. Yes, we have trees on vacant lots that might be volunteered species, a lot of quote unquote weed species, invasive trees, things like that. And we've got Druid Hill Park with stately oak trees. And we've got these bona fide forest areas that could be because of, you've got a street of row homes and their backyards, a street of row homes and their backyards, and the fence line between them. You can have, acre, 2 acre, 3 acres of forest with natural regeneration. They're providing heat island mitigation, stormwater benefits, habitat for birds, and Baltimore Green Space has done a lot of field-based work with the Forest Service and UMBC, a number of volunteers, and say, no, these areas are as biodiverse in terms of tree species as their rural counterparts. Some of them, not all of them. They have species of birds that are otherwise not found in Baltimore, and so on. And so it's not simply, a lot of urban ecology, I think in the 90s, even the early 2000s, said center of urban area, distance to center, and the further you are away from the inner harbor, the more biodiverse.
Amen.
And we're really debunking this with more detailed data, volunteered data collection, Megan's work, her counterparts in other cities, and also that the idea of just because it's urban, it's somehow degraded or different. And there are parts of Baltimore that very old trees, relatively undisturbed sites that have been built around. And we have sites that have been cut over and disturbed and have received unfortunate, dumping and tires and things like that. So it's not a monolith, and it's an exciting, diverse array of site types. And so that complicates things, and in a fun way, it can bust myths, which is fun.
Excellent, excellent. Megan, any questions?
We haven't had any additional questions come in. No, but yeah, very well said, Dexter. We've got some phenomenal natural areas in the city, and species here that I would spend years looking for in more rural forests and then just stumble across in Gwynns Falls Leakin Park. We did actually just have a question come in from Hussein asking, Texas generates higher wind energy than other states. Any information regarding impacts on birds? So I'm not sure if anybody here is familiar with wind energy and bird impacts, but Dexter, if you have a chance to weigh in on that.
I'm not, but what I have heard in my little bit of understanding is it depends on the whole scope. If you consider the whole life cycle of fossil fuels and what the turbine would be replacing, it's kind of a different picture than if you just look at the collisions of birds and turbines. So I don't know a lot about that, but what I do know is that it's more complex than just turbine versus fossil fuels.
Megan, if we don't have any more questions, why don't I turn to my concluding comments, and then we'll be able to do it. I want to again thank Dexter for joining us today. And Dexter, obviously you've been with us before, and it's really underlines the significance of your work for the policy implications for forestry in Maryland in general, not just for the Baltimore region, but for the entire state. And the fact that you've cited similar data from throughout the nation further underlines the value of this research for policymakers and program and project directors throughout the state, because they're working on various aspects of this, and many are looking for resources to expand their work. And your work underlines how that can better be directed to achieve the kind of consequences that all of us desire in helping shape these policies in the beginning. Friends, let me just conclude this particular Framing the Future webinar with two broad comments that I want to share with you and will return to in the future. The first is that we've now been presenting these topics continuously, month after month, for a little over a year and a half. We're excited to tell you that we have some really neat topics coming up between now and the fall, and you'll hear more about those in July, August, and September. The key that I want to share with all of you, and we hope that you'll share widely with any those involved in your network of contacts in forestry, is that we're anxious that this series reflect the key topics that you think will help determine the future of forest policy, program, and projects, particularly here in Maryland. We're looking at, first, we're building on the successes in policy development over the last few years. some really major successes just in the last legislative session with the modification of the Forest Conservation Act, the introduction of the Green Equity Act, which targets renovations of green spaces in urban areas and rural areas throughout the state. The Maryland the Beautiful Act, which looks to land trusts and how to undergird and help support their long-term maintenance efforts for the lands that they manage. And of course, the Forest Education Program to help educate landowners throughout the state about the benefits of their ownership of private property and helping to keep it in forest cover in the years ahead. Of course, the Forest Conservation Act focuses on the development process. And we're going to be looking in the next legislative session at what kinds of incentives can be offered to private forest landowners to manage their land in a more equitable fashion to enhance the stewardship values of their property to help address some of the problems of climate change in our communities. Forests obviously are a premier benefit for water quality, restoration of carbon, for mammals and birds and all the other access to nature that we've highlighted in this conversation. All those benefits that we underline specifically and continuously are enhanced when management is well done by private forest landowners. And the important characteristic here in Maryland is that 70% of the existing forest resource is in private hands. And while we can create mandates for the state, we want to create incentives for private landowners to do a better job, a long-term job, a committed job, a specific job, a goal-oriented job in this area in the future. And so that's going to be the focus of our work. If you have topics that you think would lend insight, knowledge, and perspective to these issues, we hope that you will feel free to go to MarylandForestryFoundation.org or gallenbay@gmail and share those topics with us continuously, update it, share the email that you've seen in registering for this thing and use it for following up on these topics. We're anxious to expand our series in the future and want to continue to make sure they're relevant and appropriate to your interests. Finally, let me say one of the premier programs that allowed us to present this is the past work and commitment of our moderator, Megan Carr. And as I've always said, she was our first Mel Fellow. That program has also been expanded over the past half dozen years and now encompasses our ability to support 4 Mel Fellows each year, 2 in natural resources careers and 2 in urban and community forestry. Applications are now open for the coming academic year, and they will be open through July the 15th. If you and your knowledge know of any student interested in support for their matriculation in a higher education program in any one of those areas, please go to our website, MarylandForestryFoundation.org, and the application process is online and available now on that website. It is one of the most generous fellowships in the nation, providing $10,000 per student for an academic year to complete their matriculation. It has some specific expectations about that, but the broad line and key requirement is that you persist and succeed in your matriculation and your candidacy for a degree program. That's our commitment to the future of Maryland forestry, trying to build the jobs and opportunities for you as a student in the future. We want to help you. Please apply, please go, please share the information. I want to thank you very much for joining us today and want to thank Dexter again for his participation in the program. What a wonderful set of ideas you've shared with us today. Extremely provocative, Dexter. I really value the work that you're doing and your colleagues, and I hope that in a different context, perhaps we can return to it in the future. Megan, is there any closing comments that you would like to add?
Just reminding folks, do check the chat. Dexter kindly added links to a lot of those publications that he was referring to, as well as to his slides. So be sure to grab those before we close out. A quick copy paste will do it. And also please join us next month. We'll be talking about spotted lanternfly, details to come. But thanks, Gary. Thanks, Dexter.
Thank you, friends. Thank you for joining us today. Have a good
Okay.
weekend to all of you.
Thanks all.
Thanks, Doug.